All right, so we are going to figure out how to find points of intersection on graphs. So basically, we're going to be given two equations, and we're going to be able to work with those two equations and figure out where they would intersect on a graph without actually graphing them. So you're going to be given something that looks like this. So, we have two equations. What does this look like? Anybody remember?
Is that thing where you combine them together? I know
Kind of, but we have to do it with it's systems of equations, basically.
Nice.
Yes. So, you're going to pick the easier one. Sure, yes. And then you're going to pick a variable to solve for. So, perfect. So, all right, so we're going to solve the second one for y. So y equals 5 minus x. All right.
Is that it?
No. Is it ever that easy? Yeah, so now we're going to take this 5 minus x and we're going to plug it into this y right here.
Oh, yeah. All right. Good one. Confidence.
All right, so now we have to do what to that red part?
Square.
Right, which also means we FOIL it.
Do you get if you just square it individually, each thing in there, would you get the same thing?
No,
No.
because you end up with the middle term.
Yeah.
So basically the shortcut for when it looks like that is,
First and the last, right?
yeah, so you square the first one, you'd get 25. And then you do whatever this number is times 2 with the x, so it would be a minus 10x. And then plus x squared.
Wait, how'd you do that again?
So whenever you are squaring something, it's the first one squared, this times 2 with the x, so times minus 10x, and then this squared.
Is that like a general for all?
When you're squaring, yes. Or if that does not sound like something you want to remember, you can FOIL it. So, first, outside is minus 5x, inside is minus 5x, outside is plus x squared, but then you still end up with that. So,
So you take the first one, you do the first number times the x. And
Times 2.
Times 2.
and then the last one squared.
Okay, so you literally okay, I got you. So you square the first one, square the second one, and then combine them, and then
Multiply by 2. Yep,
That sounds simple.
it is. All right, so now we need to solve this equation for x. So I'm going to move everything over to the left side. Yes.
why is it 4x squared equals 25?
Oh gosh, it's not.
Okay, I got really confused.
I'm sorry. Equals 25. So I'm going to combine my terms together. Thanks, Daniel. All right, so I get 5x squared. And then I'm going to put my minus 10x here. So I need to set it equal to 0, right? It's a quadratic equation.
Yes.
So I'm going to move this 25 over. These should be simple enough that you can factor, but you could use a quadratic formula if you wanted to. Right, so then now I have 5x squared minus 10x is equal to 0. So I can just very easily factor that left side. I'm going to pull out a 5x, right, which leaves me with x minus 2. Right, and then now, just like with any other factoring, we set each factor equal to 0 to solve.
What'd you do with the x minus 2?
Yeah, what do you do with X?
What do you mean?
Like, how'd you get the 5x?
I divided 5x out of both of these. I'm just factoring it out. So, yes. So, like, I have a 5x squared divided by 5x just leaves me with x. 10x divided by 5x is 2. You're just removing the greatest common factor. We've done that a lot. Then you set each factor equal to 0. So then x equals 0 and x equals 2. So those are our two x numbers.
Do we have to get 2 y?
Yes.
Do we plug that back into the y thing?
Yeah, so I would plug it back in
And simplify?
in the simple one, right?
You plug in both of them?
Yeah, so you'll get two, like, so basically you're getting points, right? You're getting an x and y coordinate pair. Yeah, so like when x is 0, y would be what?
0.
5.
Wait,
Oh, I see what you're saying. Okay.
where it said X equals 0, how come it's not 5X equals 0?
Well, because then technically I'm dividing by 5, and then 0 divided by 5 is still 0. So this one just, it's x equals 0. All right, so then, again, we're plugging in up here. So when x is 0, y is 5. So that means we have the point 0, 5 is one point of intersection. And then we have to plug in our other x. So when x is 2, y is 3. So that's what your answer should look like.
Wait, where do you get the 2?
All right, x minus 2. I added 2 to both sides, so x is equal to 2. Since I know x is equal to 2, I'm going to plug it in for x here. In this equation we found, the y equals 5 minus x.
Does it matter, like, if you put, like once you get both of the separately known, both your, like, y's and both your x's, does it matter, like, how you put 0 and 5 together? Could you put 0 and...
No, you have to put the one, like, whatever I plug in for x there has to go with that y that I got. Like, I plugged in 0, so I got 5. So those two have to go together. Yeah.
Okay, that makes sense.
Okay, would you guys like to do another one?
Um,
Yes.
oh, are we gonna have to do the ones where there's 3 different things?
No,
Okay.
just 2. That would be fun to do 3, though. But,
Sorry, this just makes my brain go.
yes, Aaron.
I'm still kind of confused. 5x.
Guys, shh.
The parentheses, the x minus 2 in the yellow.
All right, so I have this equation, right? I'm finding the greatest common factor, so something I can take out of both of those. So I can take out at least a 5 and an x from the first one, and a 5 and an x from the second one. So I write that outside, and then I divide each of those by 5x to get it. So 5x squared divided by 5x is just x. 10x divided by 5x is 2.
Yeah.
Okay. All right, let's do one more example because I don't feel confident that you guys have a good hang on this, grasp on this yet. So I'm going to go to the next slide. Okay? All right. So we're going to pick an equation. I'm going to pick the bottom one, and I'm going to solve it for y again. All right?
Could you solve for x if you wanted to?
You could, yes.
Oh my gosh, my test is really hurting.
Okay, so I'm going to solve for y. So y equals 8 minus x. So, just like before, I'm going to plug that in for this y in my other equation. All right, so again, we're just foiling that blue part to get the 64 minus 16x plus x squared. All right, again, I'm going to combine like terms. And I need to get it equal to 0. Okay, so glancing at this one, I think it's going to be easier to just go with quadratic equation rather than try to factor this.
Which one's the quadratic? Is that a squared plus b squared equals c squared?
That's Pythagorean theorem. This is the
B minus equals square root
Plus or minus the square root of.
b squared minus 4ac all over 2a. Right, where a, b, c.
Wait, is that b squared minus 4ac?
Yep.
What are those two numbers in the parentheses on the?
2 and 51.
Can you zoom in on that part, you think?
Yeah.
Oh, yeah. Thank you.
Yep.
Yeah.
4 times 2 times 51. All right, so I'm going to stop here. Do you know why?
Because you're giving me time to write down the rest.
No. Why would we stop at this point?
All real numbers.
No.
You can't,
You can't reduce or anything.
well, you can factor something out, can't you?
No.
Like, divide everything by two.
Can't do anything.
Just stop.
Oh, there's a negative in the, rather.
There's a negative in the square root. So that means this answer is
I.
imaginary. So, if it's imaginary, that means there is no point of intersection.
So, we have an imaginary equation?
No, your solution is imaginary.
Oh.
I did all that to figure out.
This just means that these two equations would not intersect.
So we did all that just to realize it's not even real.
Yep. It is not stupid.
It is.
Do not call math stupid.
I'm sorry, but that
This
is
problem
why.
in particular is.
Right.
So we did all of
Because I
that
did
just
all
to.
that.
To figure out that they don't intersect. Yes.
Is there a way to
There's
know
people
that
that
they're
are
not
smarter
going to
than I am.
intersect sooner?
No.
Okay.
They go for that math, you wouldn't have those cool Xboxes, so you guys can just calm down.
Same. Hush.
I agree.
Okay, but overall, any questions on the process? Okay. So, would you guys like to start today?
Not really.
Let's be honest. If you don't start today, you're going to come in tomorrow and be like, I don't remember anything I learned yesterday.
I
won't remember it.
One
Practice problem just now.
One practice problem.
That's tomorrow's problem.
All right, I'm going to go ahead and assign it today.
So it's optional.
It's technically optional. However, don't make, all right, If you're not, I don't want you like on phones and like, I don't care if you just sit and talk, but like do something productive or take a nap. So it is on page 195, 1 through 12.
May I go use the restroom?
Yep.
Thank you.